Today, we plug an AI brain into FlutterFlow to generate quizzes on literally anything under the sun. We'll use AI to generate questions on the fly by building a custom-trained question engine. We'll get cerebral by introducing adaptive difficulty to our questions, build a content moderation and delivery pipeline in BuildShip, and store everything securely in Supabase. But most of all, we'll be making FlutterFlow do all the hard yakka. By the end of this video, you'll have built a fully functional AI question engine, able to return information about any topic, no matter how big or small. We're using the example of a quiz here, but this exact approach could just as easily power employee onboarding modules, compliance training, product knowledge checks, or even customer self-service flows. So let's dive in. We're not building just any old quiz here. We're building the quiz of everything, so it requires a robust backend. In this section, we'll focus on two key steps to achieve that. Firstly, we'll define a JSON schema for our quiz questions to come back from our AI brain. This will ensure our data is structured consistently every time. Then we'll integrate that into our backend workflow, which we'll build in BuildShip. It's this backend workflow which will tie everything together and deliver exactly what FlutterFlow needs on the front end. So we'll start here in FlutterFlow and define the structure for our questions using custom data types. We'll create a data type called question detail. This will house the question itself, the multiple choice options, the correct answer for the question, and an audio file of our host reading out the question. Instances of this question detail structure will be stored in JSON-B fields within our Supabase tables. We configured the session answers JSON-B field in the previous video. Now we just need to focus on the quiz sessions table and set up a new JSON-B field named quiz session questions. The quiz session questions field is crucial. It will store an array or a list of all question detail objects for a specific quiz session. Each element in this array will contain the question, the multiple choice options, the correct answer, and the audio of the question being read out by our host. Don't stress, I promise it will all become clear. Next up, let's set up a backend to complement FlutterFlow's front end. Now, you could quite rightly be asking, why venture outside of FlutterFlow? There's an action flow editor, API connections, and we can update Supabase. Well, a couple of reasons. Firstly, we want to offload any resource-intensive tasks, operations that demand significant processing power. Some tasks are just better run on a backend server, ensuring your app remains responsive and efficient, all the while preserving your users' battery life. From a scalability perspective, high-end resource-intensive operations require a dedicated backend, so your app can serve users at scale without performance degradation. A backend can also connect seamlessly with numerous APIs, background or cloud services that can continue running even when the user closes the app. And finally, a backend can be important to protect your intellectual property and business logic. Separating a front end and a back end is standard practice in the software development lifecycle. We're going to enlist the support of a backend workflow builder called BuildShip. There are a number of backend services, including Xano, N8N, Make, Zapier, and more. Whichever service you choose, FlutterFlow will be able to tie in and take advantage of the security, user experience, and performance enhancements you get from handing over certain tasks to a dedicated backend. So let me walk you through each node in this workflow. First up, we've got our REST API trigger. This is our workflow's front door. It receives the request from FlutterFlow and captures all the essential data we need to kick everything off from the backend perspective. Next up, we have our UUID generator. Think of it as our digital ID maker. It's going to create a unique identifier to help us keep track of the particular quiz session that we're talking about. Super important for keeping everything organized. Next up, the brains of the operation. Our web search AI node from OpenAI is where the magic really starts happening. It takes our user's topic, goes away and researches it, and returns our quiz. It's like having a super smart research assistant / quizmaster at your fingertips. This node will return a JSON schema that's identical to the data type we've already set up in FlutterFlow, so it'll connect in perfectly. Next, we hit a conditional branch. This particular conditional checks if our user has audio on or off. If they have it off, we won't worry about creating audio of our host. Next, we go into parallel processing mode. This is a multitasking node that helps us run multiple operations simultaneously. It speeds up operations by running tasks that can run at the same time. They're not dependent on each other. This is where we're going to enlist 11 labs to bring our host to life, but more on that in the next video. Finally, we have an integration node which brings everything together into one nice, neat JSON package. Then we update Supabase to keep our database in sync. And our output node wraps everything up nicely, delivering the final result back to FlutterFlow. Sort of like putting a bow on a perfectly wrapped quiz packet. Now let's tie everything back together in FlutterFlow. Everything kicks off when our user hits the Play Now button. FlutterFlow checks if the user is logged in using a global property called isUserLoggedIn. If they are, great. If they're not, they get the login component. We've made this non-dismissible, so the user has to log in before playing. If they refuse to log in, our conditional action returns false and throws up a snack bar letting them know you must be logged in to play. Next, we present the user with the quiz header card. This is a sort of loading bay while we run our backend call, get our quiz topic, research that quiz topic, and get our quiz all set up, as well as any audio. This all occurs in BuildShip. And while this is happening, our user is presented with the great big quiz of their topic. Next, we'll kick off our BuildShip workflow with an API call. We'll need to send it these variables: the topic, the thread ID, which is a way of keeping track of the session the user is playing, and their interaction with our AI quiz generator. An audio boolean, depending on if the user is playing with sound or not, so we know if we need to generate audio of our host. We'll cover that more in the next video, so for now we'll set as false. The level, which relates to the level the user is on, and subsequently the difficulty level of the questions, which we use a utility function, formerly known as code expressions, to calculate by adding a 1 to our last question answered app state variable. The country code, which helps localize the web search. Finally, we also need to send the user ID of our authenticated user. When our BuildShip workflow completes, it adds a new row for us into our Supabase quiz sessions table and sends us back an ID of that row. So here, we're running a Supabase query to get all the fields because we need it to pass onto our quiz page. We can then dismiss our custom dialog and get the user started on their quiz. We just need to send it the output from our Supabase query, which is the first row it returns back. The way our quiz page works is that it uses the last question answered app state variable to present the next question from our questions array to the user. And it gets that from the quiz sessions row, we've passed into the page as a page parameter. So here in our heading where we want to display the question, we'll get that value from the page parameter. It's in our quiz sessions questions JSON, which we have stored as a data type, which allows us to access the questions field. Now, our questions field is an array of all our questions, so we need to get the value at a specific index. This index will be equal to the value we're at according to our last question answered app state variable. While that's a lot of digging to get to a variable, it's an important one. Thankfully, FlutterFlow lets us copy it, which makes it quicker and easier to add to our list view and buttons, which also require the index of the question we're currently on. The last thing to set up is to add what happens when the user answers a question. So here in our action flow editor, we've got a conditional action that returns true if the option the user picked is equal to the correct answer. If it is, we update our session answers table, which keeps track of each question the user has answered. We create a new Supabase row with these fields. Is correct, a boolean depending on if the question was correct or not. Answered at, which is equal to the current time, a global variable. The session ID, which we get from our page parameter. And question details, which is the question's index we're on as a data type. Then another conditional action, depending on if the question the user answered was the last question of the round. If it is, we run a query on the session answers table to work out how many questions the user answered correctly by filtering on the session ID and the is correct fields. We then send this and the user off to the results page. If it's not, the user is presented with the next question in the round. So let's recap what we've achieved in this video. We've set up an AI-powered workflow that takes in a user's topic, goes away and researches it, and then produces a bespoke quiz that our user can play through, all saved safely in Supabase. In part 3 of this series, I'll introduce you to someone special, our AI quiz show host, who's basically the grumpy old man of artificial intelligence. Think less helpful assistant, and more get off my digital lawn. You won't want to miss his charming, if disarming, personality in action. If you've liked this video, please like and subscribe. And I'll see you in the next one.